Earlier in this lecture, we had a set of data, and the first column in that data was age, and so we looked at the percentage of people that owned smartphones based on their age. And so when we looked at that data, we had like age 10 and the percentage. Age would be our X and percent would be our Y. And we graphed that data, and we decided that a logarithmic equation would be best because of the concave down shape of that data. And so we have the formula here, and that is approximating the percentage of people who own a smartphone based on their age, and our data was from 2019. So in this question, we're asked at what age, so the fact that we're asked age means I'm solving for X down here, do 99%, so this is my Y, of the people own smartphones. So in my formula, I'm going to put 99 instead of Y. When we had worked with that data, we said that because the data itself was the percentages, we did not need to move our decimals. So here again, I am not moving my decimals. So you see the 99 goes in as 99. I did not move the decimal on that. And I write the rest of my equation. I'm going to use lowercase natural log because it's a little easier and it is equivalent to the uppercase that you see on some of the older calculators. So we're going to look at figuring out X. And what we want to do is do everything possible to get X alone. So I'm first going to add the negative, so add 157, because as the opposite of subtract 455 to both sides. And I do this because when we learned to solve equations, we said you want to take care of any addition or subtraction first. So that is why I'm picking to do this first. Adding here is using the concept of the inverse. And so I see those two canceling, and I also have to add to this side to keep my equation balanced. Put my equal bar, and so I get 256.455 is equal to 88.12 natural log X. So the next thing, just like I would on any equation, I'm going to divide, and that's because it's the opposite of multiply, and I see that the 88.12 is multiplied by the natural log, so I'm going to divide by 88.12 on both sides. So divide 88.12, divide 88.12. Natural log X equals, and over here, and I did round a little bit, I got 2.9103. Now I have natural log X, and so I need to cancel that natural log to get X to truly be by itself. And it's tempting here to think that it's multiplication, because we use the parentheses to denote what we're taking the natural log of, but natural logs are not multiplication. Natural logs give you exponents. And we learned that the inverse of a natural log is base E. So inverse of natural log is base E. And this is our inverse property that we had when we went over the properties of logarithms. So because of that, I'm going to put a base E on both sides. So I come over here on the left, I now have E exponent of 2.9103. On the right, I now have base E exponent ln of X. Now, our inverse property tells us that when you have base E and a natural log of the exponent, that cancels. So these guys literally cancel. And that gives me just the x on the right-hand side of the formula. So this side is x. On the other side, I have something that is calculator friendly. So I'm going to go to my calculator. I'm going to hit second and the LN button. That brings up e to the, and I'll type in 2.9103 for the exponent. And I get 18.36 years. So I'm going to round that 18.4 years. So what this is telling me is that by age 18, a little beyond 18, 99% of people are going to own their own smartphone. And I solved using the inverse property, which was one of the two properties that we said we will use here in college algebra. And this one we used a base e because it had the natural log in the problem, and so the inverse of the natural log is base e.